chart, we'll go distance, speed, time. Start that way. What information do we have here to put on the top? Travels 15 kilometers in still water. Downstream, the same amount of time it takes to go upstream. So we are going downstream and upstream. What data do we know right away? Okay, what can I put in for speed? For down, would 15 go in the down or the up? We don't know where. 15 is when it's at still water, right? Okay, so we can't, I mean, we could, if you wanted to, you could add still water here, but he's not traveling. We know that this is 15 in still water, but he's not actually traveling any distance in still water. So this part here you don't really need, but maybe you just want to have that off to the side for information. Do we know how far he's traveling? Yes. Both 8 in both direction, right? Oh, 12 down, right, sorry. 12 down, 8 upstream. Okay? What are we trying to find? The current, right? So let's invent a variable. Now we have to invent a variable. What we don't know is the current. Are you okay with the letter C for current? Will you be going faster or slower downstream? Faster. What would I put in here? It's going to be faster than 15. 15 plus the current. Does that make sense? However much that current is going, you're going to add that to your speed. And then 15 minus C here, because it's going to be causing you to go backwards. Have you ever been on an airplane and actually thought how fast you're walking towards the washroom? Right? If you're going to the washroom at the front of the plane, and you think about how fast you're walking to that washroom, you know, you could tell someone, I was on a plane, I really had to go, so I ran to the washroom at 345 kilometers per hour, or 500 kilometers per hour to make sure I got there. Yes. How long did it take you? It took me about a minute, so I maintained that speed for about a minute. And now we can use our formulas here. Time is distance over speed, so we have 12 over 15 plus C equals 8 over 15 minus C. So the first complicated thing in these questions is filling out our chart. Recognizing what we don't know, how we would put that into the chart. And now that we've got our chart, there's got to be something in this question so that we can make an equation. So where is the sentence or where is the piece of information in this question to make an equation? Okay, that's what we want to find. We want to find what C is, but how do we, and we need to make an equation to determine that, but what would the equation be and where is that in the sentence? Yeah, Austin? Okay, so we've got, in that sentence it tells us that it takes the same amount of time. So that means these times are equal to the same thing, and if they're equal to the same thing, then we can set up our equation that this time, 15 plus C, has to equal this time. These would be grouped together. It appears that you guys like the common denominator strategy. In this case, now when you multiply both sides by 15 minus c, 15 plus c, those would cancel out. And you might see that this was one where you could have used the cross multiply, because it would have worked out that way. Now we're going to get 180 minus 12c equals 120 plus 8c. Combine your like terms, 60 equals 20c, so the current is 3. What are our units? Kilometers per hour? Is that the units we're using? Yes. What are our non-permissible values? C can't equal 9. C can't equal 15. Those non-permissible values actually make sense. Okay? If the current was 15 kilometers an hour and you were traveling upstream, what would happen? You wouldn't actually be traveling anywhere. It would take you an infinite amount of time to go 8 kilometers or 12 kilometers. You'd be very frustrated. Hopefully after an hour you would realize that it was pointless. All right, the questions that are time, distance, speed ones are 8, 11, 12, and 13.